Our next student is Michal Podhradsky, who is studying electrical and computer engineering. His thesis is titled Agent-Based Controller for an Insect-like Robot.
Good afternoon. Have you ever heard of a robotic bee? These bees are useful because they can, for example, go to a dangerous place, dangerous area, imagine like old factory, and scan there for like levels of radiation or presence of toxic chemicals. So you don't have to send there people which would risk their lives. Also, while they are in such factory, shall we say, they can make a map of that environment so the rescue team knows where to go exactly and where to pick up the survivals. And also, because they are robotic bees, they can do artificial plant pollination. So how does it work? They have different flight mechanism than, let's say, airplanes. They have two wings which are flapping at some given frequency, generating lift. If such bee wants to go higher, it just has to flap faster, so it generates more lift. If it wants to turn, for example, left, one wing has to flap faster, produce more lift than the other one, and the bee turns. You can see on the right, it's a prototype of the robot. It has very fine carbon fiber wings and 3D printed components, as well as two little motors which are spinning the wings. So to have these be useful, you don't really want to use them in like a remote control or something, you know, with a joystick, control where to go. You just want to take like a handful of them, throw them in the air, and let them do their job. So they have to be fairly smart. And that's where the agent-based control goes in. So in the brain of such a robot, there are little agents. Each of these agents has its own tasks, its goals, defined behavior, and these agents can communicate together and have some kind of hierarchy set up. So for example, agent 1, what it does, it just looks forward. If it sees an obstacle, it goes right. Agent 2 is just watching the battery of the robot, and if the battery is too low, it says B, go home. So such B with only two agents would kind of wander around in space, not doing really much, just avoiding obstacles, and if it got tired, it would just go home. So now we want to extend it. So there's agent number 3. What agent number 3 does, it just look around, finds an interesting place to scout, let's say there, looks like food maybe. So it says B, go there. But while it's going there to its destination, the other two agents are still in place and they're like watching around. So it means it will still avoid obstacles as it needs. And also if it gets tired, i.e. the battery gets low, it just returns home. This shows that the agent-based architecture can model complex behavior even with simple agents. Like each of these simple agents is really nothing complicated. And also it's very modular. So if you want to extend another behavior, say, let's say, pollinate plants or do something more complicated, just add more agents. Thank you.